Good day, students. Today we are going to look at waves once again. We have watched the videos of waves in our website, physacademy.com. Today we are going to look into some questions in waves, and we're going to take different aspects bit by bit. Now, the questions we're going to look at now come from the topic superposition of waves, and the series of questions we're going to look at now are questions that deal with path difference and phase difference. Path difference and phase difference. We want to see how they have been brought in past questions from various boards. The first question, I have about 8 or 9 questions here. I'm going to solve question number 7 first. In your PDF document, you see the PDF under this video in the comments. You will download it and go to question number 7 first. So question number 7 is on it says, let me zoom in a little bit if you can see. If you can see like this, I think you should be able to see it very well like this. I will not need to zoom in. If you need to see it better, okay, let me zoom in more. Okay, I think you can see it better now, but I become so dark for you to see. You don't really need to look at my face. It is the question over there you need to view. The frequency of radiation used in a microwave oven is 2.45 times 10 raised to the power 9 Hz. Show that the wavelength of the microwave radiation is about 12 centimeters. This question, many students, you are supposed to show this, the frequency has been given to you. You are supposed to tell the examiner, show the examiner that the wavelength is 12 centimeters. How do you go about this? One thing students forget here is that microwave is one of the electromagnetic waves. It's one of the electromagnetic waves. Let me clean this one off so that I can use this to solve some questions. So it's one of the electromagnetic waves. And remember, your electromagnetic wave R inverse G. R inverse G. Microwave is one of them. Microwave is one of these electromagnetic waves. If microwave is one of them, since they all have the same speed, the speed of light, they all have the same speed, the speed of light. Now, which is 3.0 multiplied by 10 raised to the power 8 meters per second. This is the speed. So the microwave you have been given here has the same speed. So what do? And you have been given, so, and you remember V equals to F lambda. This is easy for you. The only problem you have is not remembering this, that microwave is one of the electromagnetic wave. That may be the only thing you forget. Now, what do? Simply bring 2.45 times 10 to the power 9. .4 times 10 to the power 9 as the frequency times lambda is equals to 3.0 times 10 to the power 8. Then it is solved. Lambda will then be equals to 3.0 times 10 to the power 8 divided by 2.45 times 10 raised to the power 9. And your answer will be around 12.1 to 12.2 centimeter at the end of the day, or as the case may be. So you get it, you get your answer, you convert to centimeter. You're going to get 0.121 or 0.122. You are going to convert that to centimeter. So that's it. Divide this and you convert your answer to centimeter. You convert your answer to centimeter. When you divide this, you are going to get a particular answer in meter because we have used SI unit for everything. We use S here and we use meters per second here. The answer you get divided by, because it's going to be in meter, divided by 100, you will get about 12.2 centimeter. That's the question number 1 you have for you. And we have not finished the question. The question continues by saying, the diagram shows two different paths. Okay, the diagram shows two different paths by which microwave can reach point X. Let's look at the diagram they are talking about. This is the diagram. This is point X. That's point X. So the diagram shows two different ways by which the microwave can reach point X. One path is this. From here to this point, then it moves here. And the other part is from here to this point, and it reflects back there. So they all met here. So this is 22.1 plus this. The wave coming from here goes like this. It reaches here and it goes here. So the first part is 22.1 cm plus the second part is still on the first part, it reflects same way 14.0 centimeter. So that is one part. When you look at this, it gives you 36.1 centimeter is the path from this side. Let me call it from A to X on that side, part A. Let me call it part A. And part B, which is coming from the microwave through 20 and 10. So you calculate that, and 20 plus 10 centimeter, which gives you 30 centimeter. So you have two different parts for this microwave. You have two different parts for this microwave. So these two parts I've created for you. I've given you a path difference. From these two, you are going to get a path difference. One is 36.1 and the other one is just, one is 36.1 and one is 30.0. So you have what? You have 6.0 centimeter. I believe they are all in centimeter. All in centimeter. So we have 6.1 centimeter. 6.1 centimeter is what we have here. Now, the question says, find the path difference is what we have done. Find the path difference to reach path S. Find the path difference. Find the path difference. That's what it has told us, and we have done that. So we have seen the path difference. Now, what is the next thing after the path difference? It's now telling us the next thing is assuming waves do not reach point X along any other path. Assuming the microwave does not reach that point from any other path. It's asking us whether we are to explain now whether you would expect this point to be a microwave node or antinode. We all know. Now we are going to explain whether it's going to be node and antinode. We all know, don't forget, that node, from your videos that you have watched from the website, you know that at node, there will be total cancellation. That means phase difference is 0. Phase difference is 0. So they are totally in phase. They are completely in phase. They meet completely in phase at that point. If it is at antinode, they meet totally out of phase. If it is a node, sorry, they meet totally out of phase. If it's a node, 180% phase difference. I'm sorry to say, when they meet at node, if it's a node, 180 degrees phase difference. And if it is antinode, if they meet at antinode, then it's going to be what? 0% phase difference, or 360 degree, or 2 pi. You remember that. So if they meet in phase, it's going to be an antinode. If they meet completely in phase, antinode, completely out of phase, it's going to be a node. And what about the path difference? If they meet completely in phase, remember that the path difference will be a whole number, number of n. Lambda will be equal to path difference if they meet in phase. This you will get antinode. Completely in phase, they will superpose or intercept. They will interfere constructively. They will interfere constructively at that point. However, if they meet out of phase, it's going to, the path difference is going to be n plus another half of lambda. So it's going to be something and a half lambda. So what you are calculating now, you already know the path difference to be 6.1 centimeter. 6.1 centimeter is the path difference here, 6.1 centimeter. You want to calculate this wavelength if it is in, you want to calculate this path difference if it's in line with these rules. So let us look at it. Don't forget, we got what? 12. We're supposed to calculate it as 12 or 12 point, we got to about 12.2 as our wavelength. So if lambda equals to 12.2 centimeter, and our path difference is 6.1. If I say path difference 6.1, so n, whatever I calculate as path difference divided by lambda, if it is equal to a whole number, that means it is equal to n. If it is equal to a whole, that means they are meeting completely in phase at antinode. If it is equal to n plus another half, that means they are meeting completely, they are meeting interfering, they are meeting destructively, completely out of phase. So let's look. Path difference is what? 12.2 centimeter divided by 6 point, sorry, we got path difference to be 6.1. So let's make that mistake. 6.1 centimeter. And what do we have there? We have this as 12.2 centimeter. So this one, 1, this one, 2. So path difference over lambda is 0 plus half. Don't forget 0 is also a whole number. So it's n plus half. So n plus half will give us what? It will happen, is it constructive interference or destructive interference? Of course, we have, destructive interference, and this gives us a node. That is the first answer to that question. So it happens at a what? At a node. So at a node. That's 3 marks for you there. That's 3 marks for you. So microwave ovens use 2 separate microwave frequencies to overcome this problem. You see, when you are heating now, you are going to have uneven heating because some areas, it will meet at some area at like point X now. Where is it meeting? It's meeting where? They are meeting at a node. That means there is no wave there, no heating. That place will be cold. How can you overcome this uneven heating? And in some other areas inside the microwave, it may give you what? It may give you antinode, constructive interference. How do you overcome this? This is what this other question is asking us. How do we overcome this? We can overcome this by using microwave with what? 2 separate frequencies. If we use they're asking you to explain now separate microwave frequency. Microwave oven use 2 separate microwave frequencies to overcome this problem. How? You should explain how this is done. How is this done? Now, microwave like this, I'll explain to you. I don't need to write anything on the board and you think you should understand. Now, when you have microwave, 2 separate frequency, if you have a source from here, having a frequency, and at this point, maybe it's a node. Nothing is supposed to be formed there. Maybe you have another source here, and it's forming antinode there. So that effect will be cancelled. So if you have microwave with 2 different frequencies, so that means a node, you have the other frequency, you have 2 different what? Wavelengths. And wavelength, this is the way you will write it. The first point, that means microwave with 2 separate frequencies, we have what? We have 2 different wavelengths as V equals to F lambda. This is the same. This is different. This has to be different for you to get the same answer there. So, because this is the same, microwave, even all electromagnetic waves have the same speed. So you have this 3.0 times 10 to the power 8. This is different. This has to be different. So if the wavelength is different, what happens to the path difference? Remember, path difference divided by wavelength equals to n or n plus half lambda. Equals to n or n plus half. Path difference divided by lambda should be a whole number or a whole number plus half. So that means if they have deep microwave of different wavelength, that means path difference also will be different. Path difference will be different. So a node at a point will be antinode. A node at a point from one source may be antinode. That same point may be antinode for the other point. So the first point is that you state that if the microwaves have different frequencies, that means different wavelength. As V equals to F lambda, V is the same. First point. V is constant. 2, because the lambda is related to, wavelength is related to path difference by the equation PD divided by lambda equals to N. So if it has formed a node at a point, it is formed, if X is a node at a point, it is very possible that that same point will be N plus maybe antinode. It's forming N plus half there now from our calculation. So it's forming at node. This time around, PD over this may be N, which is node. And the manufacturer must have calculated very well to make sure a node at a point is antinode. From a source is antinode. A point that is at a node will be antinode from another point, or antinode node at the other point. So it must have been calculated like that in the construction of the microwave. So let them know wavelength is different because frequency is different using this equation. Let them know our wavelength is related to path difference, and path difference will dictate, path difference of our wavelength will dictate whether it is what it is going to be formed at a node or antinode. In my next short video, I will take another shorter question, also a little bit like this, so that you understand this type very well. Good day and God bless.